finally, we are going to explore one more method to solving quadratic equations. As discussed in the previous video, we have factored to solve quadratic equations. We've graphed to solve quadratic equations. And in the most recent video, we learned how to take the square root of both sides of an equation to solve a quadratic formula or a quadratic equation. Sometimes none of those work very well. Sometimes those just don't give us nice solutions, or they're not factorable, or we graph it and we can't tell where our line is crossing the x-axis. We have another way, and it is something called the quadratic formula. Now, this method will always work to solve quadratic equations. However, it can be a little messy. It can be a little complex. So the first thing I'm going to do is just reintroduce what the standard generic form of a quadratic formula or a quadratic equation looks like. Ax squared plus bx plus c is equal to, and when we solve them, we always set them equal to 0, typically. These are going to be very important. The a, the b, and the c. The coefficients of x squared and x, and then the constant. We have to be able to identify those. So let's just look at an example here. Let's say we have 3x squared plus 6x plus 1 is equal to 0. We can see that this is in that standard quadratic form, second degree trinomial. They're in descending order. It's equal to 0. So we can see that a is equal to 3, b is equal to 6, and c is equal to 1. This, and this. We're going to use those three numbers in a very specific formula to calculate the solutions to this equation. So here's the quadratic formula. The quadratic formula. This is one of my favorite equations, my favorite formulas. Because we're trying to solve the equation, it starts off x equals, and then is a big fraction. In the numerator, we have negative b. So here's b, it's going to be negative b. And then we've seen this before, plus or minus. So it's going to have two solutions. One is going to be plus, one is going to be minus, whatever comes next. Then we have a big radical. So the square root of. Inside this radical, b squared, there's that b term again, minus 4, the number 4, times a, so the a number, times the c number. Well, I use the dots to show multiplication. Often you'll see it written just as 4ac. But when you actually go to evaluate it, because you sometimes have negative numbers here, it's really good to put those in parentheses. So that's just a good habit to get into, 4ac. And I would even say the same thing here. This b sometimes is negative. We always want to make sure, especially with negative numbers, we put them in parentheses. B squared minus 4ac. And it's all over 2 times a. Again, this will have parentheses when we actually write it out. So let's do it. Let's solve this. So I want to solve 3x squared plus 6x plus 1. X equals, big fraction. Negative b is negative 6. There's our 6. Plus or minus the square root of 6 squared. So in parentheses, I'll put the number 6 squared minus 4 times a is 3. And then times c, which is 1. In the denominator, we have 2 times a, which is 2 times 3. This is now just a big calculation that we have to do. So we're going to do x equals negative 6 plus or minus. Inside this radical, there's always a lot of work to do. 6 squared is 36 minus 4 times 3 times 1. Well, that's going to be 12. All over 2 times 3 is 6. Let's keep going. X equals -6 plus or minus the square root of 36 minus 12 is 24, and it's all over 6 again. Now, depending on the program that you are working on, this may be enough, and it really depends on what the question asks for. The square root of 24 is an irrational number. If you try to calculate it, it's going to be a big decimal. So you have to pay attention to the instructions. If it does not say give it as a decimal and round it, then you just want to leave it as a radical. Sometimes you may need to simplify it. If you're working in ALEX, you actually don't need to simplify it. This will be fine. But in some cases, you might. So what we're going to do is simplify this just so we can see what it looks like. So x equals -6 plus or minus 24 is 4 times 6. Because 4 is a perfect square, we can bring that out front in the form of a 2. So we take the square root of 4, bring it out front as a 2, and then the 6 stays in, and then there's another 6 still on the bottom. If we want to cancel something, if we want to reduce it, all three of these things would have to have something in common. They would have to have a common factor, and they do. They all have a 2 in common. So what I'm going to do is I'm going to factor out a 2 from the numerator, 2 times -3 plus or minus. This we never factor out of the radical. We're only factoring out of this. This is just a 1 now, and I don't even need to write it. I'm just going to put it as the square root of 6, because I could redistribute this 2 and still have what I had on top. On the bottom, I'm going to re-separate it into 2 times 3, just so I can then see that the 2's cancel. And what we're left with is x equals -3 plus or minus the square root of 6 all over 3. This is the simplest format. I like this. If you are putting these into ALEX, it is also okay to give it in the unsimplified form as long as you've done all the calculations. Again, you'll often have to write these out in a comma-separated list instead of using the plus or minus sign. So this would look like -3 plus the square root of 6 over 3, comma, -3 minus the square root of 6 over 3. There are your 2 solutions. Let's do another one. This one is for you to try. So let's solve 2x squared equals 9x minus 5. So before we apply the quadratic formula, we always have to have it set equal to 0. So we're going to rewrite this as 2x squared minus 9x plus 5 equals 0. I subtracted 9x from both sides and added 5 to both sides. Now we identify our a, b, and c. A equals 2, b equals -9, and c equals 5. Do you remember the quadratic formula? X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Let's do it. If you haven't yet, pause the video and try to work this out on your own. X is equal to, big fraction bar, -b, which is -9. Make sure you get both negatives in there. Plus or minus the square root of, careful here, we have b squared, and b is a negative number, so I'm putting that in parentheses, minus 4 times 2 times 5, 4ac, 4 times 2 times 5, all over 2 times 2. Now let's clean it up. X equals, big fraction bar, -9 is 9, plus or minus the square root of 81 minus 40, all over 4. One more, x is equal to, big fraction bar, 9 plus or minus the square root of 81 minus 40 is 41, and it's all over 4. And this is one of those cases where there's actually nothing else we can do in this case. 41 has no perfect square inside of it, so it can't be simplified at all. That is it. This would be our final answer. And again, if we're entering our solution into Alex, we would do that as a comma separated list. 9 plus the square root of 41 over 4, and 9 minus the square root of 41 over 4. Now, our last one is going to have a slightly different instruction. It's going to say solve the equation and round the solution to the nearest hundredth. So this one is going to be done as a decimal. The nearest hundredth, how many decimal places is that? You'll have a number, you'll have a decimal point, and then 2 more numbers after that decimal point. This is the 100th place. So here's your equation. 7x squared minus 6x equals -1. Let's solve it. We need to first set it equal to 0. 7x squared minus 6x plus 1 equals 0. Now we will, that's right, identify our A, B, and C. A equals 7. B is -6. Did you catch the negative? And C is +1. Let's write that quadratic formula one more time. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Let's see what happens here. X equals, big fraction bar, -6, there that is again, plus or minus the square root of, in parentheses, -6 squared minus 4 times 7 times 1, all over 2 times 7. Let's clean it up. X equals, big fraction bar, +6 plus or minus the square root of 36 minus 28, all over 14. One more. X equals +6 plus or minus the square root of 8 all over 14. Now, if we had not been asked to round the solution to the nearest hundredth, we'd be done right now. This would be an acceptable answer. It can be simplified, but this would be okay. We, however, were told to round it. So here we need to use our calculators. So I'm going to pull my calculator up, and not like that. Let's get this off to the side. There we go. And of course, that's still not what I want. Let's just do this a little bit differently. Okay. So it depends on the calculator that you have, how you're going to do this. I always recommend focusing just on the numerator first. So I'm going to start by taking the square root of 8. I'm going to take, it's a little tricky on this calculator on Windows. So I'm going to take the 8, and I'm going to take the square root of it. And as you can see, it gives us this big, long, messy decimal. I always recommend that if you have a calculator that's a little more powerful than this one, and you can do more than one calculation at once, you just type in 6 plus the square root of 8. In fact, I actually think we can do that here. 6 plus the square root of 8. Yes. So the square root of 8, as we said, was 2.82. And if we add 6 to that, we get 8.82. So that's what is in our numerator when we're adding. Then we are going to divide by 14, which equals this decimal here, 0.6306. It's said to round to the nearest hundredth, so that's going to be 0.63. X equals 0.63. But we have another solution to go. So I'll start by doing that again, except now I'm going to do 6 minus the square root of 8. And you can see how it pulls that whole thing in here. I forgot that this calculator can do that. I do have to hit equals again to do the 6 minus the square root of 8. 6 minus radical 8 is 3.17157. Okay. If you are forced to do one step at a time, always take your decimal out 5, 6 places when you're doing these calculations. Now what we'll do is finish by dividing by 14. So dividing by 14, and that's going to equal another decimal. And this time we're going to round it to 0.23. That 6 is going to cause that 2 to round up. So 0.23. So these are approximations. These are estimates. You have to be very careful. Does my solution need to be exact like this, or does it need to be rounded as a decimal? In any case, this is the quadratic formula, which can be used to solve any quadratic equation that's solved for 0 simply by identifying the numbers that are in the positions of A, B, and C.